Hello everyone, welcome back to this ARSET training on assessing extreme weather statistics using NASA Earth Exchange Global Daily Downscaled Projections Coupled Model Intercomparison Project Phase 6 or NEX-GDDP CMIP 6. This is the last part of this training. In part 2 today we will focus on extreme event statistics during 21st century using NEX-GDDP data. Our guest speakers today are Dr. Hugo Chioli from NASA JPL and Alexander Goodman from NASA JPL as well. We'll also have Ashish Panta from University of Utah, and we will be hearing from them soon. Let's start with a brief review of part 1 about NEX-GDDP CMIP 6. Dr. Bridget Thresher described about NASA Earth Exchange, which is a collaborative supercomputing and data analytics platform to improve availability of Earth science data from NASA missions and models. We talked about downscaling, which is a process that transforms coarse resolution climate model data into high resolution suitable for regional and local impact studies. We talked about two types of downscaling, dynamical and statistical. And finally, NEX-GDDP CMIP 6, it is a statistically downscaled output from 35 of CMIP 6 models at daily global 1/4 degree output. There are 4 shared socioeconomic pathways considered: 2.5, 4.5, 7, and 8.5 from 2015 to 2100. And it's created using two-step methodology, bias correction and spatial desegregation. We also talked about NEX-GDDP CMIP 6 data variables and how to access them. We saw that there are 9 daily downscale variables available: surface relative and specific humidities, precipitation, surface downwelling, long wave and short wave radiation, near surface wind speed, surface minimum, maximum, and average temperatures. And there is one file for each year per variable. We also saw that GDDP data can be accessed through NASA Center for Climate Simulation. That's where they're held. They're also available from Amazon Web Service and through Google Earth Engine. We had a demonstration of how to use Google Earth Engine to access NASA GDDP NEX CMIP 6 data. And we saw some JavaScript codes to analyze data. We used Nebraska in USA as our region of interest, and we looked at annual mean maps and time series between 2020 and 2100 of surface air temperatures and precipitation. We also looked at extreme cold and hot event frequencies and extreme dry and wet event frequencies. Today, in part 2, we will continue to look at extreme event statistics during 21st century using NEX-GDDP data. Today, however, we will have additional methods of looking at this data or accessing this data, and we'll talk about that shortly. There is a homework posted on the training website, and it is due on October 17th. A certificate of completion will be awarded to those who attended all live sessions and complete the homework assignment before the given due date. We'll start with today's session. So objectives for today are that by the end of part 2, you will be able to use given Python Jupyter notebook code for GDDP data access and spatial temporal customization. Recognize how to calculate frequency and intensity of extreme hot, cold, and dry, wet events for a region of interest using the Python Jupyter notebook code. Identify changes in the extreme event statistics over the 21st century for a region of interest, and visualize maps of key variables for a region of interest using NEX-GDDP dashboard. Here's the outline for today. We'll start with an introduction to computing environment needed for today, and topic will be accessing and running analysis scripts using Binder Hub, and presenter will be Alex Goodman. Then we'll talk about data access option 1 using Amazon Web Service or AWS. And topic will be finding and downloading NEX-GDDP CMIP 6 NetCDF files from AWS cloud storage to a local disk. And presenter will be Dr. Hugo Lee. Data access option 2 will be about streamlining data loading. The topic will be Introduction to the Intake Catalog for Efficient Handling of NEX-GDDP CMIP6 Data, and presenter will be Ashish Panta. There will be hands-on lab or calculating climate indices. You will be given scripts. So activity 1 will be run scripts to calculate ETCCDI, or that is Expert Team on Climate Change Detection and Indices. That there are number of temperature precipitation based indices from downloaded data. Activity 2 will be analyze and visualize the calculated indices for a specific region of interest. And discussion will include interpreting trends and patterns in the results. There will be interactive dashboard. Ashish Panta will talk about that. So I will introduce our speakers and contributors for today. Our first speaker will be Alex Goodman from NASA's JPL. Alex is a data scientist with a strong background in both software development and climate science. He has particularly strong interest in analyzing big data sets, computational science, and cloud computing. He received his MS in atmospheric science from Colorado State University in 2016. Our next speaker will be Dr. Hugo Chioli from JPL, specializing in atmospheric sciences, climate modeling, and advanced data analytics. Dr. Lee leads research that integrates satellite observations with machine learning and uncertainty quantification to improve the evaluation and prediction of extreme weather, air quality, and wildfire risks. Dr. Lee has contributed to the development of NASA's Regional Climate Model Evaluation System, or RCMES, and is actively involved in advancing digital twin frameworks for wildfire and climate applications. He holds a PhD in atmospheric sciences from the University of Illinois at Urbana-Champaign and a BS from Seoul National University. Our final speaker will be Ashish Panta. He is a graduate student at the University of Utah, working with the Center for Extreme Data Management Analysis and Visualization (CED-MAV) group at the Scientific Computing and Imaging Institute. His research interests include large-scale data management, visualization techniques, and leveraging machine learning algorithms on large data sets. He has contributed to several interdisciplinary projects focused on improving the efficiency and scalability of scientific data workflows and collaborated with domain scientists to develop user-friendly visualization tools. We also want to acknowledge and introduce two of our contributors for today's session. Professor Valerio Pascucci is the John R. Parks Inaugural Endowed Chair of the University of Utah and the founding director of the Center for Extreme Data Management Analysis and Visualization, CED-MAV. Professor Pascucci is a faculty of the Scientific Computing and Imaging Institute, a professor of computer science of the School of Computing of the University of Utah, and a DOE Laboratory Fellow at PNNL. His research interests are in the areas of scientific visualization, high-performance computing, large-scale scientific data management, and computational topology. And our second contributor is Giorgio Scorselli. He is the director of CED-MAV within the Scientific Computing and Imaging Institute at the University of Utah. He is recognized as an expert in software engineering, particularly in transitioning research into production-ready software, and has played a key role as a principal software design engineer and a co-PI on NSF DOE projects focused on large-scale imaging technologies. So with that, we'll start today's session, and I first invite Alex Goodman.
Okay, so I'm Alex Goodman from JPL, and I will discuss today a bit about the computational environment that we'll be using for this session. So the main interface that you're going to be using to do these examples is through our deployed Binder hub. And I'm sure some of you may have used Binder before, but if you are not familiar with what Binder is, what Binder does is essentially it takes an existing GitHub repository full of Jupyter notebooks and a list of dependencies, and it automatically builds an image, then executes that image for you and deploys your own isolated instance of Jupyter Notebook over the internet, and it'll have all the necessary packages and notebooks in that repository installed and ready for you to go, so you can just get straight to computing everything you need without having any difficulties doing all the installation yourself. So let's go and showcase where that is located. This is on the first URL in this slide here. So when you click on that URL, you will get into a screen kind of like this one. And the main points of interest are to your left. You'll see your files that are of importance. So under scripts, this is going to contain all the notebooks that are needed for these exercises, including Python modules and other dependencies. And then if we go back to the root directory, there's a shared folder. So this shared folder is actually a file share that has some samples of the NEX-GDDP CMIP6 data that we've discussed earlier. So we have two models, or sorry, we have one model here, just GIS, that we will be using in these examples for you. And again, this is shared, so everyone has access to this. So the last thing I want to note is that this environment is only going to be available for today. So after this session ends, you will need to go to this GitHub repository here. And this is the actual GitHub repository that the instance we just showed is built from. And this also has all the notebooks. But this doesn't have the data. So if you want to get some copies of the data, I suggest doing this while you are in the middle of the exercises today. But if not, you can either go through some of the resources that we linked earlier, or you can send an email to me or Keo, and we will get you set up with a personal Jupyter Hub environment that you can access for the duration of this training.
Thank you, Alex. So my name is Kyo, and I'm a data scientist at Jet Propulsion Laboratory. Here, I will show how to access the NEX-GDDP CMIP6 data set, another option to access this data set. So Amazon Web Service is Amazon's cloud service. The version 2 NEX-GDDP files are stored in an Amazon S3 bucket. And S3 bucket is a public cloud, and this S3 bucket is a public cloud storage system. The important point is that anyone can access this dataset without logging in or creating an AWS account. On the slide, you can see the registry page, and this is where you can find the basic documentation, and you can also browse the data repository. And here, yes, here on the AWS registry page, you will see a description of the data set, and also under resources on the AWS, notice that this one doesn't require any AWS credentials to access the data. If you click here, you can also browse the bucket and even can download the data. So for example, I selected the access model and this scenario and ensemble and variable. And okay, this is a version 2.0 like a nested if file. I click it and it starts downloading the data to your computer. Then let's go to our binder hub. And here, if you go to the script folder, you can find this Python script. This is not a Jupyter Notebook script. We provided this Python script to make your data access easier. So it's called download underscore NEX-GDDP.py. And you can run this script on Jupyter Binder Hub, but I suggest right-click this file and choose download. And now you download this file. Then what you can do is go to the download folder. Then you can run this script. And let's open this script. And this Python script is simple to filter by variable. So for example, I want to download the 3 variables: precipitation and maximum daily temperature and minimum daily temperature, like here. And also here, the output dir, this is a folder where the downloaded NEX-GDDP files are saved. And also you can choose like scenarios, and you can choose like multiple scenarios. And here are all the available historical and SSPs like scenarios. And experiment-wise, you might want to go to the AWS registry page and check if it's what kind of ensemble members like each model is providing. For example, the Access model only provides like this one ensemble from R1, I1, P1, F1. Then also you have to choose like one of those CMIP6 models. And this workers variable like set up how many files like you want to download in parallel. So in this case, like it's 6. So now it's downloading 6 files like all together. And you don't really have to change like the last one. This is the MD5 like a file, like to check if the downloaded file is same as the one on the AWS like a repository. So, and you should be able to run this script on your local computer, but you have to install like some of the Python dependencies, libraries. And if you have any questions, like we'll provide like a more detailed like instruction on the website after like today's like a session. In the next part, our rising star, Ashish, will show another way to access and analyze NEX-GDDP data without downloading them. Ashish?
Thank you, Kyo. Hi, everyone. Let me briefly introduce myself. I'm Ashish Panta. I'm a PhD student at University of Utah, and I'm doing my computer science major. So, as you all know, downloading the data from AWS buckets can be pretty troublesome. So, in this slide, I will be showing how we can stream the same data set using the intake catalog without downloading or running the download script. So basically, an intake catalog is a metadata file that points to some data that's located somewhere in the cloud. It's like a library card for a catalog thing. And the benefit of using intake is that you can easily search and browse for the available data sets. You don't have to know about any existing cyber infrastructure, or you don't have to know which models are available. So as long as you do the right query, you can easily see which data sets are available. So from the Jupyter notebook, from the binder hub that you are in right now, to access this notebook, you have to go to the scripts folder. Inside the scripts folder, we have a file named streaming via intake. Double click that and you will be seeing the Jupyter notebook. So inside the script folder, there is a notebook called streaming via intake. And this is what it looks like. So all the libraries required for these are already installed with the Binder Hub. So you don't have to worry about manually installing any libraries. But once you are here, the first step is you just import all the required libraries. Some of the basic libraries are like intake, so matplotlib, numpy, and xarray. So in order to like browse through the catalog, you have to use this URL using the intake library. Once you open that, you can run the script to see what models or variables are available from this catalog. As you can see, we have almost 9 or 10 models available from this specific catalog. We have all the variables, all the scenarios, and all the time ranges for that. Now, once you have loaded the catalog, the next part is reading the data. For that, you specify the model of your interest, your variable, scenario, and the timestamp. Now, once that's loaded, in order to see the data, you just have to call this .read functionality. .read function, just like an xarray. Once you have that, you can get like a data array, unlike latitude and longitude. Now you can also set like start date and end date or any other variables you want. And it will give you the list of all the models, variables, scenarios as well. We also support other parameters like quality. So if you want to see like lower resolution data set, you can decrease the quality to -2, -4, or -6. Or you can also specify the latitude and longitude for the region of your interest. Now here I'm just using a default xarray tool to plot the data set. As you can see, it is now returning the specific lat long that I selected, and the data is way coarser. So if I want it finer and if I want like a broad global region, then I just have to go back and manipulate these parameters. Now you can see the same data set for the entire region with much finer details. And this is basically the same thing, but using like xarray. Now, in order to visualize the data, you don't have to always rely on xarray. You can use custom libraries like matplotlib as well. Now, let's say you don't want a specific date, you want like a range of date. So here I am specifying start date to 1010 and end date to 2020, setting the quality to -4. Now, what it is doing, it is basically extracting all the dates between these ranges and trying to plot it. As you can see, we have all the dates plotted here. Now, let's say you don't want a range, you just want specific dates for the variable. For that, you just specify the dates of interest and pass it as timestamps. Now, once you run this, it will basically extract these timestamps of interest and plot them. And basically, this is how you can leverage intake to query for the data sets. Now, coming back to the slides, Kyo will take over the next slide.
Okay, now let's use the downloaded NEX-GDDP files in Jupyter notebooks to calculate the expert team on climate change detection and indices. So ETCCDI indices and make maps. If you could not download those files, no worries. I think it's still I'm also still downloading those files like into my computer. We have already downloaded files from this model on the Jupyter Hub. So we have already downloaded the 3 variables here. precipitation, daily maximum temperature, and daily minimum temperature. And these three variables are those variables that are needed to calculate ETCCDI like indices. So ETCCDI is a set of 27 internationally recognized like indices for analyzing changes in climate extremes. And as I mentioned, we just need like three variables. And there are, we'll also we can visit their website, and you can, on this page, you can see the list of all like 27 indices with their definitions and mathematical formulations and references. They also provide ARSET library to calculate these indices, and we are providing Python version of these modules to calculate these indices. And for today's hands-on, we'll focus on precipitation-derived indices only. However, later, you can extend the same workflow to temperature-based indices using daily minimum temperature and daily maximum temperature data. The functions are already included in the Python modules. Yeah, you can find in this script folder and also the GitHub repository. So you will have everything you need to calculate ETCCDI indices on Binder Hub or on your local machine. And today you will working with two scripts. So the first script is, this is a Jupyter notebook that you will actually run. It loads precipitation data from the GIST model and calculate 8 precipitation indices. Actually, there are modules to calculate all of 10 precipitation indices, but I only included 8 indices like for today's hands-on lab. And this file, this Python script, is a Python module containing the subroutines, and subroutines, or like you can call it functions, like that do the actual index calculation. So the notebook is like the driver's seat, and the .py, the Python file, is the engine under the hood to calculate ETCCDI calculation. And now let's look at the notebook. So you go to the scripts folder. Okay, and this is the file. Okay, here, tab on parameter. So notice that there is this user parameter section at the top. And this is where you need to modify for your own calculation or for your own needs. So the root folder is where data are stored. In this case, we have already downloaded the GIST model data in this folder. And when you run this script on your local machine and you might want to refer to the directory where you downloaded NEX-GDDP data. And this is the model to use. And this is the scenario. Here, I chose like a historical, and the ensemble member, it's almost fixed and depends on like which model you are using. This is already a fixed value. And here, like this is the two variables for the time period, start year and end year. Because my start year is 1985 and end year is like 2014, that's why I chose the scenario like a historical. If you somehow choose some period that doesn't belong to historical, it will output some error messages. And you probably know that historical runs are from 1961 through 2014, and from like 2015 to the 2100, that's covered by one of these SSP scenarios. And be careful that we are only provide data from one model, GIS model, and only for the historical and SSP 585 on this binder hub. And and these are only settings you need to change. And let me quickly look at these Python module. And this is the supporting Python module. Inside, you will see functions that implement the etccdi definitions here. This is the same as the website. For example, RLX 5-day is period. It's a maximum consecutive 5-day like a precipitation. So internally in this function, it calculates consecutive 5-day maximum precipitation for a period, then find out the maximum value in each year. I forgot to talk about the season variable. So etccdi index is calculated like per each year, but you can get like one index like per year by using the entire annual data starting from January 1st through December 31st, or you can choose one of the seasons. So right now, like the season I chose is the annual, so it will calculate, for example, for RX 5-day, it will calculate the 5 consecutive day precipitation for the entire year at each grid point and find the one maximum value and save it as a RX 5-day index for each grid point. However, you can also choose like a JJA, which represent for the summertime in Northern Hemisphere from June, July, like August. Then it will only search data between June 1st and August like 31st. And also, probably you don't need to modify any of these like functions here in this Python module, unless you want to explore or like extend them. And this notebook automatically call these functions. And we can run these notebook together. So I executed the first cell like by clicking this play button. Then these are like some helper like functions and subroutines. Okay. And okay, so far no problem. So now it's loading this file. So there are 30 files, and because as mentioned in the last week's training, there's only one file like per each year. Because I'm loading data for 30-year period between 1985 and 2014, that's why I'm loading 30 files. Now, this is the cell calculating each of these indices. Wow, now it already completed the calculation of RX 1-day. Now it's all moving all the way to the CWD. And if you are curious what CWD stands for, you can go to the etccdi website or go to open this Python module, and CWD stands for consecutive wet days. So it is checking all the daily precipitation and find out like a day whose precipitation is equal to or greater than 1 millimeter like per day, and see if those precipitations are consecutive. Now the calculation is done. Then now if it's time to save these calculated results into NEX-GDDP file. So in this case, because my outdir parameter is etccdi underscore out, it will create and save calculated indices in this folder. And it will generate one file per each index. Yeah, so it will take some time to finish calculation and save files. Okay. Now, we've calculated the etccdi indices. And yeah, it will take some time to write the indices into NEX-GDDP files. However, as we did previously, you can find those indices calculated using GIS model here. So if you go to the top folder and share the directory, and under NEX-GDDP CMIP 6, there's a folder named etccdi, and you can find all the calculated indices here. And these files are exactly same as what your script is writing in this folder. It just takes some time. Okay, now we'll do, now using like these calculated indices, the next step is to analyze them for a specific country of your interest. And we'll do this together using this notebook script named etccdi underscore country underscore stats.ipython notebook. Okay, the notebook will load the etccdi NEX-GDDP files we are creating right now, or you can use the one we are providing under the shared folder, and the script will compute the long-term mean climb methodology of the indices. It will also calculate the annual regional averages for a chosen country. Then it will plot time series and histograms across years. And it will, lastly, it will fit a linear trend to the annual values and plot the slopes and R-square values. Okay, and let's run the script here. Yeah, this is that script. Oh, I'm sorry, I accidentally closed that driver script that's writing the etccdi like indices, and but as I told you, now it stopped writing the file. You can find the same file under the shared folder. So I already explained about what this model is doing, and now if you click this file like before, all the key settings are these two parameter cells like near the top, but here now you have to modify both like a step 1 cell and step 2 cell. And let me explain like what these are. So this data dir is where you have etccdi calculated etccdi like NEX-GDDP files. And if you complete the calculation using that our driver script, you can find that those indices in your etccdi like out folder. And you don't have to change like anything here, just to change like a data dir and or then this like a step 2 in parameters, you can now see that the file name. So here I will run this step 1. And you can find that we already provide the files for 18 ETCCDI like indices. And so this first shall like just list all the available ETCCDI calculated like files. And you have to give one of those like index files, like, and you have to choose one of these files. Here I chose this Alex 5-day file, but you can copy and paste like any of other files, yeah, among these. Then this one, region methods. So there are two options available. So here I chose like a country. If you choose country, you also have to provide the name of the country that you are interested. Here I chose Thailand as an example. And there's another option to plot a map for B box. So in this case, you are giving like a 4 boundary values of rectangular box. So these 4 values are minimum longitude, maximum longitude, and minimum latitude, and maximum latitude. But here, because I chose the country as my region method, it will ignore all the values in this B box. And we are providing shapefile like under this shapefile folder under script. So you can easily download this shapefile like and you can use your own shapefile. But if you want to use our shapefile, you can also go to this, select this shapefile folder and right click. Then you cannot download like the folder itself. I'm sorry, but you can go to the folder and download each of the files to your local machine. And yeah, so once you choose like everything, yeah, and that's pretty much everything. And this is a color map, the Python Mapillary color map name, and we are using like this color map like by default. But if you want to change it, like feel free to change to like different color map. And also, this is the folder where all the output of this script is archived. So let me just run this for this cell. Okay, now these are some interesting subroutines, and I just compile them. Now it is loading data. Okay, and yeah, already load the data and calculated the multi-year mean. And it doesn't take as long as loading the original NEX-GDDP because there's only one value per each year. Now, this one is applying the mask, and it will mask out all the data except the country you chose. In my case, it's Thailand. Ta-da! So this is a multi-year mean of Alex 5-day because the period I chose is between 1984 and 2015. This is a 30-year mean of this extreme ETCCDI index that we calculated using NEX-GDDP precipitation data. Yeah, daily precipitation data. And okay, so here's a map, and you know that these are the unit RX like a 5-day. In this case, it's a millimeter. Then how does these values distribute? Let's run the next cell. So this is the distribution. Yeah, you have to remember that this is a special distribution of the climatological RX 5 days shown on this map, only over Thailand, not for the globe. So if you choose like a B box region, it will not mask out the values outside the certain country, it will use all the values within the box boundary, but it will show the special statistics of all the values plotted here. And let's go to the next one. So here's a histogram, and this is all the statistics associated with this histogram. Then now the final thing is, okay, now we calculate the regional mean per each year. When calculating like a regional mean, we are considering the latitude. And so this is a cosine latitude, the weighted regional mean in each year. So there are 30 years from 1985 to the 2014. And you see the time series. And because there are like 2 years where those RX5 days are like much greater than the rest of the years. Well, this orange line is a linear feed, but it rarely explains the trend because of these two extreme values. Then you can also see how these RX5 values are distributed across 30 years. And here you see that there's one value. I think it was 1997. Yeah, there was almost close to the 275 millimeter over 5 days. And the second peak happened in 2006, and the 5-day maximum precipitation is over 175 millimeter. And you should remember that this is a regional mean and average over the entire Thailand. So in certain regions, the actual RX5 day values must be much higher than that. And you can go to the actual file here, etccdi. And for example, if you open this file and look at those values and check those values in 1997 and also 2006, and to see which region got the most extreme precipitation on those years. Then the last cell is just saving these plots, histogram, and also map plots. And to close our session, I would like to highlight that beyond coding and notebook, we also have an interactive dashboard for NEX-GDDP CIMI6 dataset. And this dashboard makes it possible to explore climate projection from NEX-GDDP directly in your browser, and no coding required. And I will now hand it over to our rising star, Ashish Panta, who will introduce the interactive dashboard and give us a live demonstration.
We basically see how we leveraged Intake and OpenVisuals to visualize these massive data sets. You can scan the QR code from your phone, or you can click the dashboard link and access the dashboard. Basically, we basically leveraged all the models and scenarios that we showed earlier with Intake and made them available from the dashboard itself. So once you are here, you can see all the models that are available from the dashboards. You can select any of them. We have 9 variables available and 3 scenarios for now. All 150 years of data are available from the dashboard itself. Once you specify the scenario, you just have to come back and change the year to your interest. You can specify a specific month or dates as well. If you want to, you can take screenshot and save this locally as well. If you basically, depending on your interest, you can set the user range to just visualize the data set of your interest. You can change the frame rate, and we will come back to that in a second. So we have this play button that lets you play through the data set. For now, as you can see, it's interactively fetching the data set directly from the cloud and visualizing this from this UI. There is a palette option as well that lets you choose from multiple palettes of interest. For example, I can switch to like different palettes that intrigues me. And then there is a mapper that lets that plots the data using linear or logarithmic color map. There is a resolution slider that lets you change the resolution of the data set, meaning higher resolution means more details, whereas lower resolution means coarser data. You can change this, for example, if you have slow internet speed, then you can change this to 15 or lower values, and then it will only query the data at that specific resolution, meaning you can, meaning visualizing these data sets can be way faster, even in like slower bandwidth conditions. And we have this stats button that lets you see the statistics of the data set. For example, the general stats lets you see mean, max, and average of the entire global region. As you play over time, all these are updated as well. Now we have other statistics available from the dashboard as well. For example, histogram shows you where the values lies, which range of values has the maximum frequency. And then we have CDF as well, and average over time that lets you see the average of this over the entire global region. Another functionality we have available from this dashboard is the turn on regional setting. So basically you can compare the entire global region with a specific region of interest. For example, once I click the selection box here, I can select any region from this, from the main canvas. Once I select this, you can see this pop-up menu, and you can save this data as a NumPy array locally, or you can download the scripts that you can later run and just plot this a specific region. I'm closing this for now, but once you close that, you can see the zoomed in view of that specific region here. Now you can basically compare the stats of the global region with your region of interest as well. All these statistics and features are available from this interactive dashboard as well. And the goal of this is to make the data accessible to general public and scientists as well. Coming back to the slides, I will let Kyo take over from slide 17. If you have any feedbacks on these slides or these dashboards, please feel free to reach out to us. And you can save this QR code and access the same dashboard from your phone as well. Thank you.
Yeah, now let's wrap up with a quick summary of what we have covered today. We started by providing a hands-on guide to analyzing extreme weather events using the NEX-GDDP CIMIP6 data set. For the computing environment, we used the Binder Hub, which allowed us to launch a pre-configured Python setup directly in your browser. And this ensures that everyone has the same consistent and reproducible environment without needing to install anything locally. And as Alex mentioned previously, if you need this Binder Hub like a computing environment for your homework, and we can give you an account. So please contact us if you wanna continue to use this Binder Hub for your homework for the next 4 weeks. And for data access, we explored 2 different approaches. First, you can download NEX-GDDP CIMIP6 NetCDF files directly from Amazon Web Service. And by running the script, you can get a local copies for the repeated use of those model files. Then secondly, you can also stream the NEX-GDP data efficiently into memory using an intake catalog. And this approach avoids the need for local downloads and makes workflows much faster and lighter. In the hands-on lab, we worked through Jupyter notebook scripts to calculate several ETCCDI indices. And these indices are developed by the expert team on climate change detection, and indices are based on daily maximum and minimum temperature and precipitation. By calculating these, we can identify also long-term trends in these climate extremes for a country of your interest. Finally, the Ashish highlighted the visualization component, the interactive NEX-GDDP CMIP6 dashboard. And this is a powerful tool for exploring and visualizing changes in climate variables across the 21st century. And it makes it much easier to see how climate extremes evolve over time in a way that's accessible to both researchers and decision makers without any climate science background. So in summary, you now have the tools to access, process, analyze, and visualize extreme indices using NEX-GDDP CMIP6 data, and all within a consistent and reproducible environment.
Thank you very much, Alex Goodman, Dr. Hugo Kioli, and Ashish Panta for your demonstrations and very useful information about how to access GDDP data using a number of methods, and also for providing a Jupyter Notebook code and introducing NEX-GDDP CMIP6 dashboard. So we thank you again. This brings us to the end of this training. In this two-part training, we had an overview of GDDP. We saw how to access GDDP data and analyze extreme event statistics. In part 1, in overview of GDDP, we saw that it is a statistically downscaled output from multiple CMIP6 models. Data are produced by using two-step methodology, bias correction, and spatial desegregation, and data are available at quarter degree resolution, spatial resolution, for 4 shared socioeconomic pathways shown here. Also, we saw that there are 9 variables available at the surface, including minimum, maximum, and average temperatures, precipitation, relative and specific humidity, shortwave and longwave radiation, and wind speed. We also saw that the data are available from multiple locations, NASA Center for Climate Simulation, Amazon Web Service, and Google Earth Engine. We had demonstrations of how to get data from by using GEE, and we calculated extreme hot and cold and wet and dry event statistics between 2020 and 2100 using GEE. And today we saw how to calculate ETCCDI indices using Python Jupyter Notebook code, and also looked at interactive GDDP dashboard. There is one homework assignment posted today on the training webpage. The homework is due on 17th of October. The answers must be submitted via Google Forms. In the homework, you will see that there are 2 exercises. One is based on GEE JavaScript, and the second one based on today's demonstration, and there is a Python code available for you to work on. You will be working on these exercises, and based on that, you will be answering some questions in Google Forms. Certificate of completion will be awarded to those who attend all live webinars, complete the homework assignment by the deadline, and you will receive a certificate via email approximately 2 months after completion of the course. We thank all our guest speakers and trainers for this training, Drs. Bridget Thresher and Hugo Kioli. also Alexandra Goodman and Ashish Panta. Thank you all for your presentations and demonstrations. Um, their contact information, email addresses are given here. ARSET contact information is available here. ARSET website with all the training material you can find there, and ARSET YouTube where training recordings will be available. Thank you so much for attending this training, and we will go to the question and answer session now. Yes, thank you all very much for attending today's session, and we thank our guest speakers once again. And we have a few questions, so let's address them. We also have some time to work on part 2 exercise that we will share with you. It's part of your homework, but you can start working right now. Let's start with question and answer. So first question is, why are we using Binder? I understand it is a pre-installed environment, but it doesn't come with additional compute to my knowledge. So will the Binder work on all hardware, and are there any other dependencies we should be aware of before running the installer Binder?
I can answer that question. So all the actual compute is running remotely on a cluster that's deployed on Amazon Web Services. So you do not need to install the Python packages yourself for today while the Binder Hub is up. I will say access technically does depend on your browser, but most modern mainstream browsers should work.
Okay. Next question is, why are there only 10, 12 models available? What about the rest of the models, the total 35?
I can jump in and answer that. So 10 to 12 models are available from the intake catalog only, because like it's a part of our ongoing research. In the future, we are planning to make all 35 models available from the catalog itself. But for now, you might have to rely on downloading the data or using like Google Earth Engine to like access rest of the models.
Thank you, Ashish. The next question is, how do you calculate for other season definitions like DJF, MAM, JJA, and so on? So I think you did go over it, but you can mention it here.
Yes, you can. There is a parameter you can change in the driver script to calculate ETCCDI.
You can go back and look at the recording of Dr. Lee's presentation. He mentions where you can, instead of annual, if you want to look at seasonal data, you will see that in the demonstration.
Yes, that's the parameter named season.
To clarify, sorry, I'm looking in the chat here. I think the question might have been clarified to be not just if it's just the standard for seasons, but if you want to define an arbitrary season. I think that's what the actual question is.
Oh, I'm sorry. Like currently, we don't provide the options for those customized periods. But if you can send me email, and I can help you to modify the script.
Great, thank you. Question 4 is, how do you use this data for a hydrological model like the soil and water assessment tool? So I'm just going to, what I know about SWOT, I'm just going to reply to that, and any of you can add to this. So SWOT model input, if you look at the link here, it requires temperature, precipitation, humidity, wind speed, surface radiation components. All these are available from GDDP CMIP6 models, as we saw. So you can spatially and temporally extract this data and for the region of your interest, and then input to SWOT. You'll have to look at you have to convert the format according to what SWOT requires, but data you can download either by GEE or from AWS for your region of interest. Next question is, can we access the Jupyter notebook for examples and practice? What do we need to do to extend the access to Binder Hub?
So if you open the homework and exercise page, you can find the link where you provide your name, affiliation, and email address. Then we'll issue an account and send an email with an instruction how to access the Jupyter Hub after this Friday. And until this coming Friday, September 19th, you should be able to continue to use the Binder Hub.
Great, thank you. Question 6 is, if we need to evaluate the model with a local monitoring system, for example, a local model or climate data register, how can we integrate without generating an oversaturation or bootstrapping? Any suggestion? I think you will have to download the data, right? To actually quantitatively compare with local data.
Yes, and also we do provide that script you can run on your local computer. It's named as download NEX-GDDP.py, and you download those data. And also, once you have those local data to compare with the NEX-GDDP, yeah, then you should be able to compare those data. And I could not really understand about generating the oversaturation and bootstrapping part. But if you can send me an email with the more detailed details, I will try to answer it.
Question 7 is, why are shapefiles used instead of more modern single file formats like GeoJSON or Parquet? Shapefiles are fine, but the file management is more effort, and if it's only used to clip the data from the model, the precision of the coordinates can be low.
Yeah, thank you for the suggestion. And as you know, the NEX-GDDP data has approximately the spatial resolution of 25 kilometers, and I think the shapefile we are providing has a high enough resolution to visualize NEX-GDDP CMIP6. But we know that there are other options to subset the data over a region of interest. And thank you so much for the suggestion. And hopefully using our script with this shapefile doesn't really slow down your workflow and any data analysis process.
Right, thank you, Q. Question 8 is, what is the coordinate system of the shapefile and the model? How are we ensuring that the right area is extracted?
That's why we are plotting and to check if the data is subset properly over the country of your interest.
But this is, we are using any particular coordinate reference system here, or it's geographic system, right?
Yes.
Yeah. So something like WGS 84 would work.
Mm-hmm.
Question 9 is there a way to pull probabilities from these models rather than what I understand to be specific estimates? For example, what is the 1% annual probability extreme event for T and PR in the future? So I guess it's you need further calculation for that or addition to your script, correct?
Yes, there's our matrix that we didn't calculate today. And for example, the R99P total is the total precipitation from any precipitation at above 99, like a percentile of the wet day precipitation. So those are so that R99P total should be very equivalent to the top 1% annual extreme precipitation. We couldn't include the calculation of those indices today, but you should be able to do it offline later after this training.
Great. Thank you, Kyo. We have some time and you can continue to post your questions in the chat box. Also, since we have time, you can work on the exercise. If you go to the training page, there is a homework document. And if you scroll down, there is part 2 exercise. So you can skip other questions for now, but just go to the description of the exercise and you can work on it. And because we have Dr. Kyo and his team here, so if you need any help, you can ask questions. Also, the Binder Hub is available for next 2 days just openly, so you can start working on it. And so I think, okay, there's one more question. Are the models bias corrected? If so, what is the process for producing bias corrected data?
I can answer that since I'm online.
Mm-hmm.
Yes, as was discussed last week in part 1 of the training, the GDDP files are in fact bias corrected before they are spatially disaggregated to the target grid.
Great, thank you. So we are all online still. If you have any more questions, please keep typing them in the chat box. In the meantime, if you want to access the Binder Hub and run the scripts, exercise is given in the homework session, homework of part 2 exercise. You can scroll down to homework. The link is available from the training page, and we can also share our screen here. Okay, so you can see on the screen part 2 exercise. So you can work on the exercise. And the questions you will be answering via Google form, but it's important that you access Binder Hub now, and there is also contact information if you want access to the Binder Hub after 19th of September. You can send your name and email over there, so then Dr. Lee and his team will give you access to work with the Binder Hub. So in the meantime, there's also a question: which uncertainty methods are suitable for uncertainty analysis? Perhaps, Bridget, you can also answer to this, because I think this is about model uncertainty, right?
I honestly don't know. I believe that would most likely be dependent on your application. You could look at comparing the historical, assuming you're talking about GDDP, sorry, where's the question? There we go. Oh, no, that's not it. You could compare them directly to the reference data set, which is GMFD, which again is linked in the previous, the part 1 training session has all the links to those data.
Thank you. So while you work on the exercise, I just want to thank you all for attending this series, and you will receive a survey link from ARSET. So please take a few minutes to complete the survey. This is our end of training survey that provides us feedback from you. And there will be a number of questions, so just a few minutes of your time, but it's really valuable to us to get your feedback. So you will receive that by email.
Hi, Amita. So there is a question in the chat. How is this affecting the values when the resolution is changing? It's sold in the web app. I can answer that. So the resolution, the change in resolution from the web app, it does not affect your Jupyter notebooks. It is just for quickly viewing the dataset from the browser interface interactively, and it depends on a lot of factors like your screen resolution, your internet speed, and so on. But setting that resolution slider to like higher values queries for more data and give you like finer details. But if you have like low internet connection, low bandwidth connection, then but still want to run everything interactively, then you might want to change the resolution slider to like 15 or 16 or lower values. That's how it's working. It's basically like progressively fetching the dataset from the cloud.
Yes, so with the different resolution, it doesn't change the value. It's just the samples. So subset for when you lower the resolution, it is going to automatically subsample the values.
Yeah, so you can try and go to the Binder Hub and try to run at least one script so that you're gonna get used to it and see that it works, and you see the results there. You can also look at the output statistics. So based on that, you will be answering the questions. We'll be here for a few more minutes. And you can always contact us via email if you have additional questions. I see a question here. I think there is an error in the take screenshot button in the dashboard. I'm not able to take the needed screenshot with different model selection. It is downloading the same screenshot every time I try to click the button. Can you check it? I think it saves as PNG on your computer, right? Is that right?
Yes, it should save it as a PNG on your computer. There might be. I was not expecting that, but yeah, let me look into that. Actually.
So the question about part 1 and part 2 exercises, they're both, if you go to the homework document that is shared on the screen, you will see part 2 for today, and above that there is part 1 exercise, which is part of your homework. It was to run Google Earth Engine script. We didn't have that much time during the last session, so it's part of your homework. You'll be going through that. You will be running a script to get dry and wet event frequencies. It looks like dashboard screenshot is having an issue, but I guess okay, there's a question, what is the deadline for these tasks? So for this homework, this is part of your homework, so you have a month to complete. But to be able to use the Binder Hub, you will have to send a request unless you use it in next 2 days. It's free for next 2 days. Even after that, it's free, but you will have to register as a user. So there is a contact information given to you for that. But you have a month to finish homework. So if you look at the screen right now, it says contact us. That's where you have to just click on the link and send the information asked to you. No, the contact is given in Ashish or Kyo. Can you type the contact information here in the chat for the Binder Hub? Okay, well, we still have a few more minutes if you have any additional questions. Otherwise, you can work on the exercise, and if you have any problem with that, you can also post your questions now about that. Okay, there is one question about what does the stats table show in the country scale?
Oh, the stats table shows the summary statistics of the values that are plotted on the map.
So is it area averaged over the country?
It's all from all the values just plotted.
Yeah. So the follow-up question to the previous one, it's just calculation R5. What about other indices?
Yes, so if you run the first cell, it will list all the files. Then if you change the file, it will show, you can choose another file for another etc CDI, then yep, you can replace that part.
The question, where is the doc part 2 exercise questions? So they are part of your homework. And once you go to the Google form from the website, you will see the questions. There's one more question about I have used, hold on, yes, sorry. It says, I have used some workflow using GitHub's code space. Can I download the given workbooks and work locally with Anaconda?
Yes. On the main page of the GitHub, you can find all of the required Python library to run the script. So
we'll be here for 15 more minutes or so, and you can continue working on the exercise or post your questions. In the meantime, I want to thank all our speakers one more time. Bridget Thresher, Dr. Kyo Lee, Alex Goodman, Ashish Panta, thank you for your contribution to this training. Also want to thank our ARSET team, Sean McCartney, Salvin Hudson Odoy, Brock Levin, Sarah Cashel, Sue Monty, Jonathan O'Brien, Maria Marabito, and Natasha Johnson Griffin. We thank our team for helping with this. And as I mentioned, you will be receiving a link for a survey. So please take a few minutes to complete the survey and provide your feedback to us. So again, I see a question about exercise 1, but you've not missed it. It's part of your homework. We did not have a lot of time to work with the Google Earth Engine script, but the link will be provided to you in the homework document. So exercise 1 is there. You can run the script and answer the questions. So you still have a month to complete everything. Part 1 and part 2 exercises and questions.
Hey everyone, I just want to give a reminder about using Binder Hub that's sort of important for the sake of these exercises. So your session is not permanent or persistent, and generating some of the data through these scripts can take an upwards of around 30 minutes. So I highly suggest that after you're done running the scripts to save the data locally, because if you decide to leave and come back later, it will not be there. So yeah, just remember, save all your data. Thank you.
So there's a question on the AWS S3 bucket. I can see the GIS E21G folder, but not the ECCDI folder. Is there another location where I have to access to download those files?
So the AWS S3 bucket provides only the original NEX-GDDP CMIP6 data. And those ETCCDI folder, you can find it under shared folder on Binder Hub, not the AWS.
There's a question in the chat box. Can I upload manual shapefile in Binder Hub?
Yes, it is possible to upload it. So if you go to the tool pane on the left side, just underneath the menu where it says file edit, view, run, kernel, etc., there's an up arrow thing. So navigate to the shapefile folder and then press the upload button. I think you can also, you should be able to right click too, I believe, and you'll see an option to upload. But again, just want to remind you all, as I mentioned earlier, all data on Binder Hub, besides the stuff that's in the shared folder, which is read-only, is temporary. So just keep that in mind.
So I have a question to that, all the shared folder files, will they be there after 19th or they won't be there? The NetCDF files based on...
Sorry, yes. So, well, that data is permanent.
Okay, good.
But as we mentioned earlier, if we want to have direct access to that, you'll need to fill out that form because the Binder Hub link.
Oh yeah, you know that's right. Okay, great, thanks.
Mm-hmm.
There's a question about running etc cdi pr indices driver. I received an error in computing the indices. That's a question, and I think you need to rerun, right? Reset all, go to kernel, reset all, and start again. Try it one more time, please. There's a question, what we did in Binder Hub can be done in GEE as well. So for now, the code that we have shared in GEE cannot do the same. ETCCDI is not calculated in there. It just calculates by some threshold. It calculates extreme frequencies, but one can write code to calculate ETCCDI in JavaScript in GEE, and perhaps we can do that. Yes, it's not available now, but it is doable.
Amita, I heard you talk about an error. Was that the person who posted the warning message in the chat about invalid?
Yes.
Yeah, you can just ignore that. You don't. That's not an actual error that you need to worry about.
Thanks,
It's gonna
Alex.
run.
So there's a question. Yes, if you have completed the homework, all the questions, then you can submit and go to the optional exercise for sure. So on the training page, you will see a Google form link on the homework. So there are more questions, not just part 2 exercise, but you go through all of them. There are about 11 questions. You will be answering those, and that's your homework. Yeah, so for the survey for the Binder Hub access, yes, all you need is to send your name, affiliation, and email. We will be closing the training in a couple of minutes. So if you have any more questions, this is the time to post them in the chat box. Otherwise, you can continue working with the homework. And we look forward to see you at future ARSET trainings. Thank you so much.